Acha. Okay, so hope you guys are well. Okay, so be careful because coronavirus is really dangerous. So sit back, and this is the lecture 3. So the day till now in the solid state structure, what we have still talked about is the classification of the crystalline structure and the amorphous, the differences between them. Okay, and then what we talked about is the classifications of different crystalline substances, right? Like cubic crystals, like different hexagonal crystals. Okay, and in the cubic crystals we talked about different lattice structures, right? Okay. Now the lattice structures basically, what does it basically is a construction unit of a total solid structure. Okay, now the solid structure, what in this lecture what we will what the point I'm trying to make is that in this lecture what I will talk about is basically the closed pack structure. Okay. The closed pack structures are basically nothing but your lattice. Okay, so while doing the simple cubic lattice, what we were doing, we were having this is the this is one face of a simple cubic lattice. Okay, so for our calculation purpose, what we are doing, we are just touching the all the spheres and connecting them via line. So this is known as the closed pack structure. In solids, the atoms or the molecules, okay, they are assumed to be in this closed pack form. Acha. Now this closed pack form is, now what we will try to do is that we will go through the different closed pack structure of the crystals, and we will see that what kind of close packing the lattice exhibits. Number one, okay, packings. Okay. Number two, see, when you pack something, let's say you are packing clothes or books. Okay, so there will be spaces between two books or two clothes. Okay, in case of crystals, that spaces we know is known as voids. Okay, and this sort of voids is basically the size of the voids is determined by the radius of the cation and the radius of the anion. Okay, now the classification I will discuss, and this is known as the radius ratio. But at this radius ratio will radius ratio and these voids and this packing together, they will the talk about the crystals, the imperfections and the perfection of the crystals. Now the abnormality in this radius ratio and the voids leads to the imperfection of crystal. Imperfections, okay, and these imperfections, it leads to our the new gives us the new direction, the new field. Okay, this is a very important thing in the solid state chemistry, is the we know is semiconductors. Okay, so rest what we will talk about in this lecture is the magnetic properties. So guys, please go through this lecture. Each the lectures I will upload about this all topics, and make sure that when we will meet next, there will be an exam. Okay, monthly exam. It will be based on your lecture 1, lecture 2, and this lecture. And okay, now if you have any doubts, so contact Pritam sir. So he will make a way to contact with me. Okay. So let's start. Okay, let me tell you one very fundamental rule. What is that rule? Is that when a solid undergoes packing, okay, packing, then what happens? The atoms are forms means atoms try to form the most closed structures. Okay, now closed structures means they will be like closed with each other. They try to be more closer, right? Okay, now the solid packing, as I said while discussing the lattice formation, what I said is that the solid packing usually takes place from one surface, okay, then it makes another surface, then makes it another surface, and then all surfaces are joined, right? So basically it's a propagation z axis. So this similarly the packing also we will look in the same way. First we will talk about the 1D packing. Okay, now combining the one dimension with another one dimension, we will say 2D packing. Okay, and then 2D plus the one dimension, we will talk about the 3D packing. 3D packing. Okay, so this way if you think, so it will be very easy to understand also, number one, and number two, you can easily remember for your final exam or concepts. Okay, so let's go one by one. So what happens in case of one dimension? In 1D, what happens? In 1D, the solid particles are connected like this way. So like this way. It goes infinite, whatever the size of the solid structure. Okay. Let's say this is along x-axis propagating. That means each of the atoms one by one is getting attached and through the x-axis, let's say, propagating. Okay. Similarly, it can go through the y-axis also. Right? So this is, let's say, y-axis. So it's a bead-like arrangement. So it goes through the one x-axis and then through y-axis. So you can take one from here also. Okay. So see here, this is a two-dimensional system. In this two-dimension, two possible arrangements can happen. See very carefully. In two-dimension, two possible arrangements can happen. One, all the molecule atoms can sit over each other, right? Or they can shift a single position. Right? Now see, if you see very carefully, in these two cases, okay, let's do another one. Here, okay. See, if you see very carefully, in these two cases, here, 4 atoms makes a small void here. So what kind of void is here? Right? So this kind of arrangement is called A arrangement. So because all are same, this is triple A arrangement, like this one. Okay. So what is this packing is called square packing. Right? So in this square packing, so obviously since it is square packing, so you will get a 4-corner kind of void. This void. Okay. Okay. So the coordination number here. Coordination number is what? The coordination number is basically defined as if you define a central atom, a fixed atom. Now the number of neighbors present surrounding that atom is known as the coordination number of that atom. Okay? let's say if this is my center atom, if, so how many neighbors is present? 1, 2, 3, 4. So 4 coordination. The coordination number is 4 here. So this is a tetra coordinated system. Okay. Achha. Now let's say in case of this kind of arrangement, what is happening here? In case of case if this is A, so this will be B layer, A layer and B layer, and this will be a layer again. So it's kind of a B arrangement. Okay. Now in this case of arrangement, if you see, they only in case the voids, in part of the voids, only 3 molecules. See here. If you see very carefully, see here the 3 is there. So it's a triangular void in first layer, in second layer, in all the layers you will find a triangular void. Okay, a triangular void, this kind of void. So it's a triangular void. Okay. Now if you see, let's say if you consider this as your central atom, so I can draw this way.